Hey, fifth graders. I just wanted to talk to you about converting between units of time. By the way, welcome to the first day of fourth quarter. To those of you that are new to the building for this year, your first time in UA for all of this year, welcome back. We're glad to have you. I'm looking forward to seeing you in the hallways. Maybe I'll be able to stop by and say hi. We'll get to catch up a little bit. But I'm very glad that we're kind of like moving back towards a little bit more normalcy in terms of our schedule and learning, which is fantastic. We're going to start this week in terms of our note cards with something pretty simple, something that most of you understand a bit. And I'm just going to riff on it for a little bit with what I explain and hope that you learn something maybe a little bit new, or maybe if not new, maybe just something like you didn't think of it that way before. You know what I mean? And what I wanted to talk about was time, because time gets tricky. Not like what I've written up here. That's pretty simple. One day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. I think we all know that. But what I think it gets tricky is when we start to talk about decimals and fractions and kind of converting back and forth, and it gets a little bit messy in a lot of our heads when we start to think about it. Like if I said, you know, let's say, sorry about that. If I ask you to figure out how old you were in hours, could you do it? If I ask you to figure out how old you were in days, could you do it? If I ask you to figure out how old you were in seconds, could you do it? And I think the answer would be maybe. Like some of you would be like, yeah, I can figure that out. But this is where we get like into these kind of like big numbers, right? And also we get into this kind of conversion. Like, if you've been alive for 11 years, let's say it's your 11th birthday, like, and you figured out how many days is that? How many days have you been here? And then you could say, well, how many hours have I been here? How many minutes have I been here? And you get into this really large number. How many minutes have I been on this planet? Right? Kind of interesting. But what I want to talk to you today is like how we kind of think about time. And one of the things that's interesting to me about time is this notion of it's not set up on 100. It's one of the things that we set up on 60-minute intervals. So most of our numbers are set up, most of our things that we kind of talk about are set up in units of kind of 10, 100,000. It kind of moves like that. And when you think about like measurement, like the metric system, that's how it's set up. But time is not set up that way. So what happens is if I come over here and I say, well, 4.5 hours. Let's change my topic here. Let's go over here and I say, well, let's say 3.5. 3.5 hours, right? Is blank minutes, right? So what I want us to do on that is to think about how would we do that problem? How would we set this up? Well, the interesting thing about it is that because this is our decimal here, what I always would recommend that you do is change this into a fraction or a mixed number. And I'd say make this 3.5 hours. And I chose zero point 0.5 because it's easy, but let's make it 3.5 hours, right? And now let's do some calculations here. In order for me to convert that into minutes, I first need to take the 3 and I need to multiply it by 60 because every hour is 60 minutes. So we're going to say 3 times 60 equals 180. So that's the first part. But now we also have a half an hour, right? So we think about half of an hour, or 0.5 of an hour, and we say, what is half of 60? So the second thing we need to do is we need to add up 1/2. So we got to say 1/2 of, which is times 1/2 times 60. And as you guys know, the same as 1/2 of 60 would be saying 60 divided by 2. Like think about a clock. If I take a circle and I say like this is 60 minutes, right? And I'm cutting it, like a clock, like tick tock, tick tock. And I cut it in half and I say we're going to take half of 60, right? The first part of the clock. How much is that? Well, I've basically chopped it in half. So half of 60 is 30. So we take these two numbers and we add them together. We say 180 plus 30 equals, and I go in my head, 80, 90, 100, or 180, 190, 200, 210, or 18 plus 3 is 21, and we say 210. So this is our answer, 210 minutes. So we're going to change our color, let's make it purple. So our answer is going to be right here, 210. I should probably put minutes in. 210 minutes, right? That's how many minutes are in 3.5 hours, right? So right here. So this is one way to think about that conversion back and forth. Notice what we did. We started with the larger unit, the hours, and we know we're going to have many more minutes in an hour. So what was the operation that we used? We used multiplication, right? Multiplication to do that problem. And that's really important, like this idea that we multiply. So now let's try another one. Let's do this one in another color. Let's do it in red, and we'll move it over to here. And I'm going to say, let's say that we're going to try to say, let's go 432 seconds, right, is how many minutes? So I could say, actually, before I do that, let's do is blank minutes. All right. Now this one, notice we are going up in this one. So I should probably draw a line here. We are now starting with the smaller units, and we need to break those down into bigger units. So on this one, I might do it a little bit differently. And I'm going to go over here and make sure I box these out so we see that these are different problems, right? So this is going to be a different problem over here. So my 432 minutes, and I don't know what color I was using this one, 432 seconds, I'm sorry, is how many minutes? And we're going to figure this out. So what we're going to do is now we started with a whole bunch of seconds, and we need to divide out the number of minutes out of it. So what I might do is start adding up 60. So if I take away 60 seconds from this, right, that's 1 minute out, right? So one way to think about this is, what if I did 432? So 432 divided by 60. And I'm doing that because I have seconds and I want to break it down into minutes, which are bigger, which means I need to divide it. If you think about it in your head, you're like, oh yeah, there's going to be less minutes, right? So I might start to think of it this way. Another way for me to think about it is, how many 60s fit into 432, right? So I might think another way to think about it is 60 times what, right, would equal 432. Now, obviously, it's not going to fit in perfectly, but I can start to kind of think about my factors of 6. So I can say, okay, I know that 6 times 5 equals 30, right? So by extension, 60 times 5 would be 300. Okay, so what that tells me is, wait a second, 360 times 5. So 5 minutes would give me 300. So I'd say, oh, it's going to be more than that. It's more than 5. So let's add another 60. So plus another 60. So let's go 300, right? And then plus 60 would be 6 minutes. Plus 60 more would be 7 minutes. That's up to 420, isn't it? So I'm going out of order here, but now I'm at 420 seconds, right? And how many minutes is that? Well, I should probably do it. Let me see, minutes. I did an orange up here. Why don't we do minutes? This is 5, right? We said it's 5 right here, so it's 5 minutes. So we said this right here is worth 5 minutes. This is worth 1 minute. And this is worth 1 minute. So we could say that that 420 seconds is 7 minutes. So that means our answer is 7 minutes. And how much is left over? So we have 7 minutes and 12, or I'm sorry, yeah. Is it 12? Yeah, 12 seconds left over. 7 minutes and 12 seconds would be our answer to that one. So when we do a problem like that, we use division, right? We divide. And we could have divided, but what I did is I kind of changed division into this idea of counting up by 60. How many 60s fit in to 432? And we're kind of moving around and we say, does that make sense? Does it make sense that 7 minutes is about 420 seconds. Yes. Does it make sense? It's 7 minutes and 12 seconds would be 432. Yes, it does. So this is how you might divide. So here we talked about like breaking it down through multiplication. Here we said we divide, and I actually took it back and did it a little bit back. I kind of worked it backwards. And I find this to be kind of an interesting thing. And maybe you find this to be a little confusing, but my idea here is I want to show you that you can kind of jump back and forth between things, right? And you can play with it a little bit. And maybe I should have picked a better example, but that's okay. We can go with it right now. So now I want to show you one more other thing. If I ask you, what is, and let's pick a new color. We haven't done much blue. If I ask you, what is 1/4 of an hour? I want you to think of a clock now. One more thing. I'm just going to give you a bunch of stuff here. I want you to think of a clock. 1/4 of a clock means we're going to cut it into 4 parts, right? And it means that we're going to just color one of these in. This is my 1/4, right? How many minutes is that? So this is a 60 seconds. So if I say 1/4 of an hour equals blank minutes, right? I want you to think about how much on a clock, on an analog clock, like kind of in our classroom, how much time has elapsed. Well, we know that there are 60 minutes in an hour. So if I'm taking 1/4 of that, I can just divide it by 4. So this would be 60 minutes, right? 60 minutes divided by 4, right? Because there's 4 equal parts. Once again, 1/4 means that you're taking just 1/4 of it, or 1 out of 4. So we're dividing it by 4, and we get 60 divided by 4 is 15 minutes, right? Now, what if, let's change to another blue. What if I say 1/3 of an hour? So this is another problem. 1/3 of an hour. I'm running out of room. All right, 1/3 of an hour. And once again, I want us to draw that. So let's take a look at a clock. Look up at a clock in your room and think, okay, I'm going to cut this into 3 equal parts, right? Look at where it falls. If you look at where that equal part falls on that clock, that third right there is the same as saying 60 minutes, right? 60 minutes divided by 3 equal parts. So that's going to equal, and I got to put an equal sign here, which means I'm going to bring it down here. That's going to equal 20 minutes, because we're dividing those 60 minutes into we're dividing it into thirds, right? And you can do that with like 1/5 of an hour. So 1/5 of an hour would be 12 minutes, right? Because you can divide by 5. So you start to see these kind of different ways of writing what things are, or you see different ways of like talking about time. So I'd like you to write this down, make this your note card. It's kind of a little bit of a wonky one, but write it down and we'll talk more about it. You'll see later in the week when we work on problems, how to kind of do certain problems with time and how to play with them. And I'm going to give you some practice problems on the next page just to work on. So I'll post those as well. But right now, write this down and then try the practice problems. And I think you'll start to see what I'm trying to get at here with my not so wonderful note card. Yeah, not so wonderful note card today. All right, kiddos. Have a great day. I hope you enjoy your first day back. And yeah, that's it. Great. It's beginning of 4th quarter. Now I got to find the stop button. Here we go.